Alright guys, we're going to graph piecewise functions, and we're going to start with the equation y equals 4x minus 2. But we only want the piece of that line where x is greater than or equal to 2. So for this first example, if you're following along with me step by step, make sure you have a pencil with a good eraser, because we will erase as we go. We're going to graph this first line just like we talked about at the beginning of class. It's in slope-intercept form. So remember, this number is our slope. The slope of this line is 4 over 1, which just means that line is rising 4 for every 1 it's going to the right. That's essentially the steepness of the line. And the y-intercept is the point, essentially, where this line starts, and it's the point 0, negative 2. So we're going to start this graph by graphing the point 0, negative 2. And then from that point, we're going to go up 4. We're going to use our slope. We're going to go up 4, right 1 from this point that we have graphed. And we're going to go up 4 over 1 several times. I'm even go one more time off the paper. Didn't have to be exactly where I've got it. But graph those 4 points. And we could also do the opposite. You will have to do that sometimes here. Instead of going up 4 over 1, we can go down 4, left 1. So that's review. Hopefully we remember that. All right, so I went ahead and connected my dots. That is a horrible line, but I think you get the idea. So connect those dots. However, we want to erase some now. We want to erase the part of the line that does not satisfy the inequality x is greater than or equal to 2. So you'll be doing this a lot today. This will usually be your first step. But I'm going to draw essentially a borderline at x equals 2. So that just looks like this, a vertical line that goes through the point x equals 2, all the way up and all the way down. So according to this information, we want only the piece of the line that's greater than or equal to 2. So that means we're going to erase everything on the line that is to the left of this green. It erased it, but we do want to keep the piece of the line that is greater than or equal to 2. This is why it's called a piecewise function. We have one piece of that line, only the piece that's x is greater than or equal to 2. If you need to pause it, make sure you get these notes, but I'm going to move on. I'm going to erase these notes here. All right, so the second function we're going to graph is y equals negative x divided by 3 plus 4. So the slope of this line is negative 1 over 3. Remember, there's an assumed 1 in front of that x. And the y-intercept is the point 0, 4. So I'm going to start by graphing the point 0, 4. And I'm going to use my slope, which this time, since it's a negative 1, we're going to go down 1 and to the right 3 from that original point we have graphed. So we're going to go down 1, right 3, down 1, right 3. And we're also going to do the opposite. Instead of down 1, right 3, we're going to go up 1, left 3. Up 1, left 3. Go and fill up that graph. Some of you may have caught on pretty quickly, but we only want the piece of the line that is less than 2. So that's everything to the left of this line. So that's everything here. I'm going to stop at this point right at that dividing line. I'm going to have an open circle. Some of you probably know why. It's because this isn't less than or equal to. X has to be less than 2, so we do not include the point where it falls on x equals 2. So that's our answer. That's our piecewise function. For number 3, we've got one piece that is less than 2, and we've got the other piece that's greater than 2. And a lot of your answers are going to look similar to this. So let's try this next one, number 4. I'm going to start by drawing the dividing line, this time at x equals 3. All right, so number 4, we've got the line y equals -3. And this is one of those lines you either know how to graph or you don't know the short way. So if you don't, again, go to y equals. All you have to do is put -3 to the right of the y equals, and then you can look at the table and see very quickly what kind of line this is. So y equals -3 is simply just a horizontal line that goes through -3 every single time. Notice what it says about y equals -3. We only want the piece of the line where x is less than or equal to 3. So we're going to graph this line up to our border, which we have listed right there. So that's the line y equals -3 graphed, where it's only less than +3. Then we're going to graph the line y equals 2x minus 5, which has a slope of 2/1. It has a y-intercept of 0, -5. So we only want the piece of this line that is greater than 3. So yes, the line should be somewhere on this side of our neon green line there. It's going to start, though, if you see the y-intercept is -5, actually starts here on the left side. So we need to go up to over 1 from our y-intercept until we get to the other side of the line. So that's up 2 over 1, up 2 over 1, up 2 over 1. This sign right here tells us whether or not it's an open or closed circle. Since its x is greater than 3, that means it does not include that point. But we want to get a couple other points, so we're going to go up 2 over 1, up 2 over 1, up 2 over 1. Graph that line, make it look a little straighter than mine, and this is our answer. That's that piecewise function with both of the pieces graphed following those rules where x is less than or equal to 3 or x is greater than 3. So try number 5 real quick. I want you to go ahead and pause it. I'm going to give you the answer here in just a little bit, but I want you to pause it. See if you can do a problem like this on your own. You may have a couple of these short problems on a short quiz tomorrow. But give this one a try. You may or may not get it correct, but give it a try. Pause now. I'll give the answer in just a bit. Just in case you're confused on how to start it, the border line should be right through the y-axis where x is equal to 0. So there's the first line graphed for number 5. That should be y equals -x plus 1, where x is less than or equal to 0. So that's half our answer. All right, and there's the second line graphed. It really takes you off the grid to graph that second point. But notice the open circle because it does not have the or equal to. And on the blue line does have a solid dot because of that or equal to. So make sure you include that. I'm hoping at least it's making somewhat of sense so far. If you're still struggling, please ask for help. But let's go on to number 6. All right, so now we're looking at number 6. Notice we've got 3 equations here. We're going to actually have 2 border lines. We're going to have one border line at 0, where x is equal to 0. So that is no different than the last problem. Let me go ahead and put that up right here. And we're going to have another border line at x equals 5. So let's count over 5 spaces and draw a vertical line through x equals 5. So this time we're going to have 3 pieces instead of just 2 pieces, but it's really the same process. If you understand what you're doing, feel free to fast forward to check your answer. But I'm going to go through this problem, and I'm first going to graph the line y equals negative x plus 4. And I only want the piece that is less than or equal to 0. So that less than or equal to means I'm going to have a solid dot at some point when I graph this line. The slope, of course, that m, I haven't used that yet, but that's just notation for slope. The slope of this line is negative 1 over 1. And the y-intercept is the 0.04. So I'm going to graph the 0.04 right here. And my slope is negative 1 over 1. So that's down 1, right 1 from the point I have. If I go down 1, right 1, though, we get a point right here. You have to ask yourself, is that new point satisfy the inequality x is less than 0? If it does, you're okay. If it doesn't, like this case, we need to go the other direction. So instead of down 1, right 1, we need to go up 1, left 1. Up 1, left 1. And remember, this was a solid dot on the boundary line, so we're okay there. So we can sketch that first line. Okay, so we're going to sketch the next line, y equals 2x over 3 minus 1, and it has to satisfy, we only want the piece of the line in between 0 and 5. So we know the slope of this line is 2 over 3, it's a positive 2 over 3, and the y-intercept is the 0.0, negative 1. So one thing we want to keep in mind, because of these inequality symbols, we're going to have an open dot right here because it's not an or equal to, but we're going to have a closed dot right here since it is or equal to. So let's graph this line. And a lot of times if you just graph the whole line and then you erase afterward, that's easier for some people to do. So I'm going to start at the 0, negative 1. And I'm going to go up 2 to the right 3 from that point. So up 2 to the right 3. Up 2 to the right 3. And we could do the opposite. We could go down to left 3. But again, we only want the points in between 0 and 5. So when we graph our line, we are going to connect it to this point here, but we're going to stop at that borderline right here. And we're actually not going to get to this other point, so we need to erase it because that point's not in between 0 and 5. Again, the hardest part for some people may be whether or not it's an open or closed dot. Again, this is a closed dot because of that or equal to sign right there. So now we're ready to graph the last line. So the last line is the line y equals 2. Again, that's just a horizontal line where y is always equal to 2. So essentially it's this line right here. But we only want the piece where x is greater than 5. So we only want the piece that starts at this boundary line and goes to the right, because that's where x is greater than 5. So we don't want the purple line, everything to the left. So that should be our complete answer on number 6. Okay, guys, we're doing the opposite of what we just talked about. Now we're going to write equations for the graph that we're given here. So we're given graphs, we're going to write equations. So the first thing you should notice, pretty obvious, where this graph kind of deviates, it changes course right at the origin. So that's where our boundary line is going to go. It's going to go right through where x is equal to 0. So we've got two pieces to this graph. One piece is the piece that is less than 0. So that's everything to the left of that boundary line. The other piece is everything greater than or equal to 0. And you may ask, how did I know that was greater than or equal to? I really didn't. In this particular problem, they didn't give us an open or closed dot. So you could have very easily made this the or equal to inequality in the problem. It doesn't really matter if they don't tell you which one has the open and which one has the closed dot. So first we want to write an equation for this piece of the problem right here, for the piece that's less than 0. And you recall, to write an equation, you need the m and you need the b. So we need the slope of this line, which is rise over run, and we need to find the b, which is the y-intercept of the line. The b should be very easy in this problem because you can actually see where it crosses the y-axis. It crosses at the origin, crosses at the point 0, 0. So that means our y-intercept is just 0. The slope takes a little bit more work, but not much. We need 2 points on that line. So find any 2 points where it looks like it crosses the grid lines. Looks like there's a lot. I find these two that are really close to one another. And remember, slope is just rise over run. So we're going up 1, over 1. So the rise over run in this problem is 1 over 1, which is just 1. So that's our m in this problem. So we know what the m is, we know what the b is. So the equation of this line is y equals 1x plus 0. Like I said, you do not have to put the plus 0. I just put it there just to kind of show you how to write the equation. It wouldn't be wrong if you wrote it, but you don't need it. You also don't need the 1 in front of the x. So that's the equation for the first line. So now we're going to look for the equation for the other half of the line, circled in blue. We're going to go through the same process. This doesn't always happen, but the y-intercept again for this one is 0, because that's where it crosses the y-axis. The rise over the run of this line, again, pick 2 points where it definitely crosses. So it definitely crosses at those 2 points I have labeled. And we're just going to count up and over. So we go, the rise is 2, the run is 1. So our slope is just 2 over 1. So that means the equation of this line is y equals 2x. We don't need to put the plus 0. And we've now written a problem for the graph given here. So let's do one more, number 8. So first we want to find our boundary line. It's right here at -2. So you look at our boundaries, it looks like the first one, and this time they do have open and closed dots. This line over here is everything where x is less than -2. Doesn't have the or equal to because it's not a solid dot. Go ahead and write the other one. The other one is everything where x is greater than or equal to -2. So we just need to write the equation of first the line in blue. This one's going to take a little bit more work to find the slope and to find the y-intercept. First, we actually want to find the slope of this line. So pick 2 points. This part's actually pretty easy. If we pick 2 points and we rise over run, you see the slope is just 1 over 1. Of course, 1 over 1 just simplifies to 1, x plus, and now we just need to find the y-intercept. And we can find that, a lot of you probably already have it, by just going up 1 over 1 until we intersect the y-axis over here. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and you should see this is my y-intercept, that point. So that's the point 0, 5. So that means my y-intercept is 5. So the equation we have circled in blue is the equation y equals x plus 5. All right, so the other one, this is one either you know or you don't. So if you don't, here's, I guess, the long way to come up with it. To find the slope, pick any 2 points. The rise over the run, in this case, we're not going up at all, but we are going over. So the rise over run in this case is 0 over 1. Which, of course, 0 divided by 1 is 0. I'll fix that in just a second. And then the b, the y-intercept, you can clearly see the y-intercept. It crosses right here at the point 0, negative 2. So the y-intercept is negative 2. So this becomes y equals 0x minus 2. But 0 times x, we don't need to write that. 0 times x is just 0. So the equation of that line is y equals negative 2. And there's our answer to number 8.